How are you, my dear class 8 English version students? In the previous class, basically, we also explained about the orbits. Here, I will also draw the three orbits. There are also the fill-up first orbits. It's also the 2 electrons. In the second orbits, we also know that they are fill-up the 8 electrons. And the third orbits, we also explained that they are also the fill-up of the 18 electrons. Now, our new topics. Here's the new topics. I also select the lesson 9 to not 9 to sorry 12 to 13. Here's the 12 to 13. We also explain the electron distribution and the properties of elements. Very important, and also the last topics in this chapter. Here's the properties of elements are basically determined by the electron distribution in their orbits. Generally, atoms become active or inactive or charged. Basically, again I also repeat, the atoms become their behavior basically active or inactive or charged due to differences in electron distribution. Here's I also draw again this figure. Here's this figure, basically the first orbits and the first figure. The first orbits figure, they are also the fill up the 2 electrons. And the second orbits, they are also the fill up the 8 electrons. And the third orbits, they are also the fill up the 8 electrons. When they are also the fill up, then they are not the active. Basically, they are also the inactive, and they have no any electron or the negative, positive and negative charge. When they are not fill up and they are also the empty electrons, then they are also the types and also their behavior. Basically, their behavior is the active and also the charged structure. Now, if the last orbit has all the electrons that are alloyed in that energy level, again I also repeat, if the last orbit has all the electrons that are alloyed in that energy level, then that orbit is completely filled. This type of atoms is inert. For examples, there are 2 electrons in a helium atom. Again, I also draw this structure. Basically, this structure is the helium. When the helium structure, this structure is the first orbit, and they have also the atomic number is 2. And in the structure, basically we also follow the first orbit. As the first orbit, they have also the 2 electrons, and they are also the fill up. Again, and this is, and I also repeat that if the number of electrons in the last orbit or the highest state is such that it can complete it either and the borrowing electrons or losing electrons. Sorry, again I also repeat, the first orbit is allowed to have 2 electrons, therefore the helium atom is the inert and stable, and every atom tends to go to such a stable state. Now, if the number of electrons in the last orbit or the highest state is such that it can complete it either by borrowing electrons or losing electrons, it will tend to do so. Again, I also explain. Here's when I just draw the hydrogen. Here's the hydrogen. Basically, they have only 1 electron, and I just draw only 1 orbit, and they are not fill up. They are not fill up. Basically, they have, when they fill up first orbit, they have also the another electron, but hydrogen have no any electrons and only 1 electrons. When this is because when the outermost orbit is complete, the negative charge of electron shield the equal number of protons in the nucleus. This reduces the energy of the system, and the atom becomes more stable. This redistribution of the outer electron takes place by sharing the electron with the neighboring atoms. For example, consider the case of sodium atom. It has 2 electrons in the first orbit, 8 electrons in the second orbit, and 1 electron in the third orbit. If the sodium atom can lose the single electron in the third orbit, its outermost the second orbit becomes full and the atom will become stable. My dear students, I just draw again this structure. Here's the sodium, here's the sodium, their atomic number, here's the sodium, the atomic number is the 11. So, we just follow this structure. Here's the first orbit. In the first orbit, they are also the fill up, the 2 electrons, and they are also the stable. In the second orbit, they are also the fill up of 8 and they are also the stable. My dear students, I just draw 1, 2, 3, 4, 5, 6, 7, 8. When the third orbit, they have also only the 1 electron and they are not that stable. And the neighboring, the another structure, again I also repeat, by sharing the electron with the neighboring atoms. For example, consider the case of sodium atom. It has 2 electrons in the first orbit, 8 electrons in the second orbit, and the 1 electron in the third orbit. If the sodium atom can lose the single electron in the third orbit, when they lose the third orbit is also the only 1 electron, and the third orbit, its outermost second orbit becomes full and the atom will become stable. The sodium atom will easily lose 1 electron from the third orbit. If some neighboring atoms has the tendency to grab an electron to fill its outermost orbit. But when the sodium atom loses 1 electron, it is no longer charged neutral. Normal sodium atom is charged neutral because it has the same number of protons in the nucleus as the same number of electrons in the orbits. By losing 1 electron, the sodium atom becomes positively charged. This charged atom is called an ion. If the charge is positive, it is called the cation, and the sodium by the losing an electron becomes an ion. When they are also the losing, they are another structure is the cation, and when they are also the another structure is the name is the anion. Now, let us take another example. Fluorine. Again, fluorine has this structure is the sodium, and the another structure is the fluorine. Here's the fluorine. This atomic number is the 9. I just draw this structure is the basically fluorine, and the atomic number is the 9. Again, I just draw the first atomic number, and also the orbit is the 2 electron. Here's the second structure is the only the 1, 2, 3, 4, 5, 6, 7. When they have only, if they have only the 1 electron, then they are also the stable. So please, my dear students, please everyone see the boards. Sodium has 1 orbit, the third structure, and the fluorine has the second electron, and this structure is not second electron, sorry, second orbit. They have also the 7 electron. When the sodium give this the electron, then they are also the 8 and they are also the stable. Again, is it not funny? Yes, is also the funny structure. And by losing 1 electron, the sodium atoms becomes positively charged. This charged atoms is called an ion. Then the sodium is the cation. Again, I also explained this structure is the cation, and the fluorine, they are also the anion. And cation is the positive charge and the anion is the negative charge. Now let us take another example. Fluorine atom has electron distribution 2 and 7. Is it a stable state? No. Surely no. For stability, it needs 8 electrons in the outermost orbit. It can either lose 7 electrons from the second orbit or can grab on 1 extra electron to complete the second orbit. From the energy consideration, it is far more favorable to snatch 1 extra electron to complete the second orbit. In the vicinity of sodium atoms, it can easily take 1 electron from the sodium atom. After receiving 1 electron from outer side, the fluorine atom becomes negatively charged. This makes is a negatively charged ion. It is called the anion. Here's the page number 66. Thus, by receiving or losing electron, atoms becomes ionized. Of the two atoms, the one which lost electron becomes cation. The atom which grabs electron becomes anion or negatively charged ion. As a result, an attractive force works between these oppositely charged ions and they form a bond. In this way, atoms of elements forms molecules of compounds. You will know more about the higher classes. Just I also explained that another structure is the, my dear students, here's the sodium. Again, I just draw this structure. Here's the sodium, and the sodium they also gave the one electron. Yes, I just draw this structure. Then the positive charge. This structure is the positive charge, and they also gave the one electron. And the second structure is the fluorine. Here is the fluorine. This structure is the F and plus. They also take, yes, they also take the one electron, and this structure is the anion and also the negative charge. My dear students, I have just finished only this the structure of atoms of the chapter 6. Basically, this chapter is the chemistry based chapter. We also know the previous class. The structure of atoms. First structure, we also know the evolution of the idea of atoms and their structure. Second category is the lesson 4 to 6, atomic number, mass number and isotopes. The third number and also third lesson 7 to 8, the properties and application of isotopes, very important topics. And the lesson 9 to 11, the way the electrons are distributed in an atom. Now, my dear students, I have also selected the last topics today. As the last topics today, lesson 12 and 13, the electron distribution and properties of elements. Here's what we have learned at the end of this chapter. Atoms are not indivisible. Atoms are formed by electrons, protons and the neutrons. At the center of the atom there is the nucleus. In the nucleus there are positively charged protons and the charge-free neutrons. Most of the mass of an atom is in the nucleus. Negatively charged electron revolves in definite orbits or shells with the nucleus at the center. The space between the electrons and the nucleus is empty. In fact, most of the space is in an atom is empty. The first orbit can have maximum of 2 electrons. We also explained previously. The second orbit can have maximum 8 electrons and the highest number of electrons for the third orbit is the 18. These orbits are also called energy levels. If the highest orbit has the number of electrons with the maximum number allowed, then the orbit is completely full. Such atoms are inert. Atoms become stable and ionized by receiving or losing electrons. My dear students, I hope everyone learned from this the topics, the structure of atoms. Thank you. Hope everyone is also the fine. Goodbye.